Adding and subtracting. Rational expressions. Which means that I'm probably going to have x's and y's and all kinds of things. Binomial terms and everything. But let's take a step backward in time. If you had 2/3 plus 5/7, what do you remember from adding and subtracting? You have to have a common denominator, right? Before you can do anything else, you have to have a common denominator. And sometimes, depending on what it is, the easiest way that we could have found a common denominator was take 3 times 7, right? And it happens to work for this one. As was stated, the common denominator is 21. What do I have to multiply this 3 by to get me to 21? Which means that I have to take 7 times the original numerator, don't I? And I have a reason for writing it that way, because you're going to use it that way in just a couple minutes, okay? To go from 7 to 21, what do I have to multiply this 7 by to get to 21? So I got to take 3 times the original. What? 7 times 2 gave me 14 over 21 plus 15 over 21.
Yep.
Which gives me then about 29 over 21. I could add these because they're similar, aren't they? Right? Okay? So you remember how to do that. Okay? We're going to take a simple problem. Let's take 3 over 2x plus 7 over 5. Oh, I got an x, don't I? Won't change anything. Will not change the process. It may change the looks. I have to find a common denominator. So first I would find the common denominator between 2 and 5.
Yes.
10?
Yes.
What's the common denominator between x and nothing? And it's easy with variables, because if I have a variable, you look for the largest exponent.
1.
So in this case, it's a 1, so I'd have 10x, 10x. Alright? What do I have to multiply the 2 by to get to 10? 5. What do I have to multiply the x by to get to x?
X. 1.
1. 1 times x will give me an x, won't it?
Yeah.
So I got to take 5 times 3,
Yeah.
right? The multiplier times the original numerator, correct? What do I have to multiply the 5 by to get to 10? 2. What do I have to multiply? I don't have any variable here.
0.
So what do I have to multiply that by to get to x? An x, don't I? So I got to take 2x times 7. So that's going to give me 15 over 10x
14x over 10.
plus 14x over 10x. Well, okay, nice idea, Jagger, but if I reduce, guess what I end up with? What I started with.
Jagger, you do it.
Well, does that make sense? Right now, if I reduced,
I just want to use my brain.
I put these in common denominator so that I could add these, couldn't I?
Yeah.
So what's 15 plus 14x?
29.
14x plus 15 all over 10x. I put the x term first. I put it in descending order. So we really aren't doing anything new we still have to get a common denominator, don't we?
Yep.
We still have to add things together after I've got the common denominator. So I'm not really surprising you with anything new in process, just surprising you with something new in the way that it looks. Okay? All right, now we're going to try a hard problem. What an evil laugh. Gotta find the common denominator, don't I? What is the common denominator between 2 and 8?
66. Or 8.
8.
Oh.
Wouldn't that be the least common denominator?
Yes, it would.
Could I use 16?
Yes.
Absolutely.
Good.
I could use 16, but when I get done, I'll be able to take a common factor of 2 out of everything. I can guarantee you that.
Yep.
Okay? Between the x cubed and the x, I said, look for the highest exponent, right? Which is x to the third, x to the third. Well, I've got a y over here, don't I?
Yeah.
No y here, so I look for the highest y exponent. Y to the second, y to the second. So it's actually very easy to find the common denominator of variables. Look for the largest exponent. Kind of simple, huh?
Yeah.
Kind of scary. Now, what do I, going from 2 to 8, how do I multiply by the 2 by to get to 8? 4. Go from x cubed to x cubed. What do I have to multiply x cubed by to get down to here? 1. Then what's 1 times 4?
4.
Okay. I'm going from nothing, or a 1, to y squared, correct? So don't I have to multiply by y squared? Times the original numerator, which is 3y. What do I have to multiply 8 by to get to 8?
1.
1. What do I have to multiply x by to get to x cubed? X squared. What do I have to multiply y squared to get to y squared?
Y.
If they're the same, I multiply by a 1, don't I? So these are the same, aren't they?
Yes.
And what's 1 times 1?
1.
1. Times what?
Z. Times Z.
5z.
You want to drop your Z to the bottom? Like X?
There is no z in the bottom.
Or, oh.
I don't see
You
any.
only take the biggest variable.
In the denominator.
No, in the denominator.
In the denominator. Because I'm getting common denominator. Okay? So I multiply up here. So what's 4y squared times 3y? 12y cubed over x cubed y squared plus 5x squared z over 8x cubed y squared. Have a common denominator, don't I? So I look, are there any similar terms? In this expression, there's no similar terms, correct? Absolutely none. But I want to write it over one denominator, which means I put them together. All over 8x cubed y squared.
I do like terms of together.
If there were like terms, I would add them together. But there's no like terms between 12y cubed and 5x squared z. Right? There isn't any. That wasn't so bad, now was it? Ready for part 2?